Now, before switching to some exterior rendering, let's see what we can do with these images. Now, like to add some details, or in terms of materials, as well in terms of final image. I wouldn't say post-production, but adding some interesting effects could be quite nice for creating a more realistic look and feel for the final image. Normally, rendering tends to be too much perfect, and this is something that might result also disturbing for the client or for the observer. So let's see how to add some quick and nice effects to our images. Remember that actually the settings that we have right now are, yeah, more or less, you already see the preview that you are getting. So we have a nice HDRI image illuminating the scene. So we have this kind of light pouring through the window and reaching also the other room here, and then here being casted on floor as well as on the wall, and some nice reflection for the paintings and so on. So we already have quite a nice result with this image. Let's see what we can add in order to make it a little less perfect. Effects, normally you see that there are some effects are inside the camera tab, but other couple of effects will be in the general V-Ray settings here. So first of all, let's take a look at these two here. So vertical lens tilt is something that you might want to use when you create a rendering with vertical distortion. So it's normally, this is an effect that allows eliminating or reducing the vertical distortion that you get in a 3-point perspective. We are not going to use this because our scene, well, basically doesn't have this kind of problem, okay? Because it's a very small scene. But when you render large building or very tall buildings, then in this case, vertical lens tilt might be useful. But vignetting is an effect that tends to make the corners of your image darker. This is something that well, might sound useless, but actually it is an attempt to reproduce a natural phenomenon that happens in standard cameras, and this is due to imperfections or to poor quality in the lens that you are using in your camera. So it's basically the lens that avoid light entering the camera in a uniform way, so it gets darker around the border of the image. And you see, for example, let's see if we can reduce, yeah, okay, so let's reduce render quality, so to increase render speed, -4, let's see if we already get some quicker pre-pass. Light cache is already quite fast, so we don't need to tweak the subteams in this case. But we reduce the radiance map quality, it should be faster. Yeah, you see that squares move, the bucket moves quite faster around the scene. And now it's going to be interesting as well to take a look now at the final result that we are getting, because this is, hypothetically speaking, we are considering a very low quality for irradiance map, as we discussed in the previous session. And of course, if you use these settings in a totally white environment, any artifacts or any problem that you might get with this poor light calculation quality becomes extremely evident. But in this case, you can see that due to the fact that we are already using material and some effects like reflections and so on, then those kind of problems, well, start to disappear, basically. So not always you must increase light calculation quality, especially if your image is going to go through a post-production process, then eventually you might also render the final image in V-Ray with poor light calculation quality, and then take into account that you will have some post-production process that will eventually eliminate any of the artifacts that you are getting here. So this is the actual render that we have. I want to also, well, it's basically, it's very easy to remember. You see that all the scene actually is is perfectly bright, also when it gets to the corners. Okay, so vignetting, if you activate with vignetting, you will have, well, let's push it a little higher, this value. So we're going to have a look at the final result, and I'm going to render only, well, not this area, because this is slower to render. There is more light here. So what I'm going to do, I'm going to render only this third of our image with vignetting activated. So let's see. You see that it has become completely black. Only you start to see something from the shelves to the right. So let's decrease this to half the actual value. You will see that we will start to have some rounding here with this black area. Now, this is very much, I mean, this is a very high value for vignetting, but I wanted to show you quickly the result. Normally, if you give these very small values, like, I don't know, 0.4, the effect that you get is slightly visible, should be slightly visible. Like in this case, you might notice that you have these corners are getting darker. This is the effect of vignetting. Even slighter than this, it should be just a very light effect that you get on the corners. Else it becomes to be extremely evident and also fake. Okay, so this is something that eventually you might want to create also in post-production. It's a very basic effect. You just simply add some gradient, semi-transparent gradient on the corners, and you get the same result, and you can control it better in post-production. But if you want, you can also add vignetting here in V-Ray. So it's a very, let's say, it's almost invisible as effect. So we can also render this corner here in order to see the difference, because it is pretty uniform white or gray in this moment. Let's see if we, yeah, it's just a little gray, darker gray here in this area. Okay, so you can see the difference between these and these, for example. But anyway, it's a very basic effect. I do recommend actually that you don't use vignetting in V-Ray, but you reproduce this effect in post-production with some photo editing software, because in that case you have more control and you don't have to re-render the image on and on each time you tweak this value. Okay, let's get rid of this. And let's go to the, well, let's say interesting effect. Now, interesting effects are these two here, volumetric environment and denoiser. First, I'm going to discuss volumetric environment, because it's something that it's always a pleasure to work with volumetric environment. It also adds some mood to our images. So what I'm going to do, I'm going to go on the outside of this house, and I'm going to look at this house from top, because there are two different volumetric effects that we can create. And I'm going to add an infinite V-Ray infinity plane in order to have some ground plane here. Okay, so our house is actually lying on this horizontal plane. This house is not, well, this model is not good for exterior in this moment, because it lacks few details. Well, for example, the roof. And also you might notice that there is no filling here in the walls, and the wall is incomplete here on this side, because this model is meant to be seen only from this side. Okay, so it's not complete, but nevertheless. And remember that this house has a height of 3.5 meters. Okay, so and what I'm going to do, I'm going to place here next to this house another building, which is going to be some kind of tower. Okay, so quite a tall building. So we have this scene right now. And if I V-Ray interactive render this, as our settings are good for an interior, we might see that this image get totally or almost totally burnt. So we must go into V-Ray settings,
the final result,
go into advanced
nice
camera parameters, and then eventually here, you see we have
nice
some
volumetric effect for light
very
pouring
slow
inside this,
shutter speed.
room
So
through
in
the
this
windows
case,
on the right.
eventually
You see
we might
these
start
stripes
ranging
here,
from
and also
300
these rays of
or
light
about
being
300. You see that we
intercepted
already have
by,
some nice
light by
visibility
the
for
air
our
inside our
objects.
room. So very
Eventually,
nice effect.
a
The
little
rendering becomes quite slower,
little more light.
but of course,
Yeah, something like this.
whatever
Okay, so
settings you
let's
tweak
start with
inside the
volumetric
interface,
environment.
no one
If
intends to
I
make your
turn
life
this
easy,
on,
so this is not surprise. But
you see that the image becomes
absolutely worth
almost totally white.
creating this,
The reason why it's turning so white and so burnt is not because there is too much light, but because there is too much fog. Also, you see that there is a sun that you can select. Actually, I switched to none because I don't want to use Rhino Document Sun. Rhino Document Sun is a light that is naturally present in any Rhino model and that you cannot delete. Okay, so I don't want this fog to interact with Rhino Document Sun. Eventually, if you go in and use an exterior and you want to produce an exterior rendering, you might introduce sun in your scene. But in this moment, I don't want to, so I will leave sun set to none. And this is getting so wide because visibility range is set to 6,000, which is 6 kilometers, basically. And also all the atmosphere, which is basically the volumetric environment in this case, is also set to 6,000. So it means that we have horizontal visibility of 6 kilometers and vertical fog up to 6 kilometers. But if I activate the camera F6 and go into a, I don't know, oh, this should be a front view. I think I changed it like to a perspective. So if you go into a front view, you see that our camera lies at a certain height, but it's not 6,000. Okay, so this point here, we can also, I think that we can also analyze this point and see that the height is 80. Okay, so if I set this atmospherical effect to reach up to 80 meters, then you see that we start recovering some visibility in our model. And you see that this is actually 80 is quite a small value for this scene because 80 is the position of the camera. So there are only 80 meters here where this atmospheric effect can happen. But if I, for example, double this value, then my camera is already inside the volumetric effect. Okay, so we start to have this kind of more less clear view of the scene. Okay, and also the visibility range is still set to 6,000, so we can see up to 6 kilometers from here. But my camera is more or less lies at, we can also calculate in this case the precise distance that we have between this point and the target point, which is 100 meters. So if I set this visibility range to 200, you see that we can no longer see through the fog. Okay, so if I set this to 1 kilometer, for example, I start to recover some visibility, but fog is affecting the environment. Because if you can see up to 6 kilometers and your object lies at 100 meters, you can see perfectly the object, right? But if I set this visibility range to a higher value, then objects start to be submerged by fog. Okay, so if I set this to, for example, 200, remember that the distance camera to target is 100, so you see that 200 is too few in order to see something. But if I start to have some more interesting values, then in that case I recover some visibility. Okay. Now, when do you use this volumetric environment in type aerial perspective? when you have some flyby over cities or over very wide landscapes, then you might use this aerial perspective volumetric environment. Okay. In our case, we are not. Well, actually, what I want to do, I want to work in our interior. So I go back in the interior scene, and you see that in this case, if I use aerial perspective,
you can see
there
how
is
nice
a,
is
well,
to
I would say a
have
dumb
this light
volumetric
being
effect, because
visible
it's a
when it
very
enters
diffused
this
fog
environment.
that we get.
Now, there is one
In this
thing
case,
that
if you want to work in an
personally
interior
I
scene, or
would
you want to control
but
volumetric
it's
environment
impossible
at the
in a
ground level
mathematic
or
way.
at the puber level,
The
you better
V-Ray
switch to environment fog.
doesn't allow texturing.
Now, environment
this
fog is
effect.
totally different.
This is something
It's,
that
you handle
eventually you can do
environment
in
fog
other software,
more or less the same way,
but not
but the effect that you get
at least in this version
are
of the
absolutely
V-Ray is
stunning
not yet possible.
as regard, for
But to
example,
add
interior
some
rendering.
texture in order to have some
For example, distance
irregular
works exactly the same.
of
So if I have distance of 1 kilometer, remember that now we are in an interior scene. So the distance between the camera and the target is more or less, as you can see, 1, 2, 3, 4 meters. Okay? And our camera in this interior scene lies at a height of 1.75, if I remember correctly. So 4-meter distance, and we are inside a room that measures 3.5 meters in height. Okay, so distance of 1 kilometer means that we can see basically everything inside our interior scene. The farther points that we have here might be at the distance of 10 meters top. But if you take a look at the environment out of the window, you start to see that there is some fog. So from the distance, due to the fact that we are considering a visibility range of 1 kilometer, you might see some environment fog happening right now. But if I reduce this distance to something that's in range, considering the viewport and the point of view that we are using and the range of visibility that we have. So for example, if I set this to 10 meters and we wait for this to update, you see that we don't see absolutely nothing. What happens in this case is that we have the distance set to 10 meters, but also a volumetric environment fog that is set to work up to 200 meters. So there's a lot of fog in the first 200 meters of height. Our room measures 3.5 meters. So if I set this to exactly 3.5, which is the height of our environment, we start to have some nice volumetric effect inside the room that is visible to the camera. Now, why is this phenomenon so interesting and important? Because this is the effect that you get, for example, when you have some thick air inside a closed environment. So let's say that this room has not been open since months. Okay, so you have very thick atmosphere inside, and then light penetrating this environment starts to be visible because the air is filled with particles of dust or whatever, right? So this is the effect that we are looking for. So if remember that we because we switched to an exterior view, we tweaked the parameter of our camera. So let's go back to a slower shutter speed in order to capture more light in this environment. And you start see this white fog here, which is the light intercepted from the projection of this light here. And also you start seeing this light pouring inside the environment from the windows here on the right. Okay, so if I, for example, stop this interactive render and create a production rendering, so remember that this interactive must go away, so we can work with actual global illumination settings. And let's re-render this scene. And let's wait a little, but now it's going to be worth the waiting, because you can see so many interesting light effects going on right now. So you can see the final result is a very nice rendering where we have this nice volumetric effect for light pouring inside this room through the windows on the right. You see these stripes here, and also these rays of light being intercepted by the air inside our room. So very nice effect. The rendering becomes quite slower in this case, but of course, whatever settings you tweak inside V-Ray interface normally tend to make your rendering slower. So this is not surprise, but it's absolutely worth waiting this time because the effect is absolutely amazing. There is also another scene that I have prepared here, which is this interior 2. I'm going to switch this to this scene because in this case I have more windows visible. So I will produce also a rendering of this scene in order to also have the other perspective. Let me also activate the history, V-Ray frame buffer history. I'm going to save everything inside our working folder, and I will enable autosave and only completed rendering, so we will be able to. Let me get rid of previously saved rendering. Let's save only this one, and I'm going to save also this new render here. And here's the final result. You can see how nice it is to have this light being visible when it enters this environment. And now there is one thing you can see how nice it is to have this light being visible in an automatic way when it enters this environment. Now there is one thing that personally I would love, but it's not possible in an automatic way. The V-Ray environment fog doesn't allow texturing this effect. This is something that eventually you can do in other software, but not in this, at least in this version of V-Ray, is not yet possible. But to add some texture in order to have some more irregular distribution of this volumetric effect, not like this uniform effect that we have here. The only difference in light that we see is due to the fact that there are some non-transparent objects that avoid light to be to filter inside this environment. Okay, but nevertheless, this is a very nice effect to play with, especially in an interior scene. Or you might also work with this in an exterior scene where you want to simulate some thick air in the environment. So imagine, for example, the light filtering through the branches of and leaves of a tree, right? So you would have a very nice effect of environmental fog, even in an exterior environment. So we have these two examples here that are already quite interesting to analyze. So I will go back to my interior 01. Also the close-up itself should look pretty amazing with this. But anyway, the other effect or the other tweak that I want to show you here in V-Ray is besides the volumetric environment that we can absolutely leave on in this case. I'm going back to this scene here, or no, the latest one was this one. So let's repeat this rendering, but this time I'm going to only activate the denoiser. Now, remember that when we were discussing the global illumination parameter, especially the radiance map parameter, we were also saying that the lower this value, the more artifacts we get in terms of light distribution in the scene. Eventually, there is the famous blotchiness effect that you get on white surfaces. Okay, and you will see now denoising. This effect is already happening in our rendering. So, for example, if I go back in my V-Ray, for example, if you decide to any of these two images, render so let's say this one. In the V-Ray frame buffer, you can also activate some light post-production effect, like here on this right panel that opens up. One of these is exposure. So if you notice that your image is underexposed, then eventually you can, instead of going back to V-Ray asset editor, tweaking light values or camera settings and so on, you can always try to make some light post-production on the final image. So let's say this image is too dark. You can activate the exposure control and you can tweak its values. Like here, you have a highlight burns and contrast also. Now, if I set exposure to the default value, which is 0, this is the original image. Okay? The only, let's say, um, pixelation that I see in this image comes from the volumetric fog environment. Okay, but if I increase exposure, you see that this effect is also visible here in this area. You might notice that there is some noise here on the wall, which is not due to volumetric fog. Now, in order to get rid of this, you should increase the quality of light calculation in global illumination. But the rendering will become extremely slower. Okay, so there is another thing that you can do, which is don't pay attention to these artifacts that you get in a standard render execution, and activate the denoiser. The denoiser is an algorithm that happens after the image, the rendering is finished, in order to compensate these variations that you get in pixel brightness. So it's basically, that's why it's called the denoiser. It gets rid of the noise that you get from a poor or an insufficient light quality from your rendering. So let's activate this. Remember that the Wireframe buffer is actually saving completed rendering in this stack here. So let's activate Denoiser, and let's go back to our interior tool, and let's re-render this scene. As you can see, I'm not tweaking any parameter here. I'm just leaving the V-Ray Denoiser activated, and it's there are many other types of denoiser. You might see here the denoiser can be set can be switched from V-Ray to NVIDIA AI. In this moment, I am using the V-Ray denoiser. It depends on your system. If you have an NVIDIA graphic card, then you can activate also the other options. I have a Quadro here, but nevertheless, you will already get the effect of the denoiser even from a standard V-Ray denoiser execution. Preset is set to default, and there is one option that I would leave on, which is mode show denoiser channel. Now, you might know that in the Wireframe buffer, there are many channels available. You see, this is the channel that you see while rendering is the RGB, which is basically the final image that you are producing. But there are also other things, other information inside this image that will be still available once the render is finished. For example, like the orientation of object in the 3D space, which is called world normals. Then there is world position, which is basically painting with colors the position in space. So X, Y, Z position. You see that there are gradients of colors here. And there are also some filters here, which are separated channels, so separated effects that you get inside your scene. So, for example, here we see that the glass here, the glass in the picture frames, the metal of this structure here, the glass of the cup, and the glass of the glass. Actually, this base here, the surface of this round table, and the floor, these are all reflecting objects. So reflection filter is actually isolating this reflection contribution inside the scene, and so on. So refraction will only be the refractive material, and so on. So you can add also several rendering channels if you want to do some very particular and specific post-production. That's why it's useful to have this separated channel at the end of your rendering. And what happens is that the denoiser will have its own channel, but as you can see, it is not present at the moment. The denoiser is absolutely black, okay? So it has its own channel, but it's not present at the moment. The denoiser happens once the final image has been calculated, because it works on the information produced by the final rendering. So he needs to evaluate the actual noise. So that's why it's not actually occurring. So you would see that once this rendering image get to the very end of this progressive bar here, then you would see that another pass will happen, which is exactly the denoiser. So here we are. And you will see now denoising two render elements based on RGB color. You can denoise almost anything in V-Ray. If, for example, if you decide to add some render channel here, you can also apply denoiser to that specific channel. So that's why it says two render elements. Now it is actually denoising just the RGB color, supposedly, and eventually another layer that I cannot identify right now. But anyway, you see that denoiser actually contains this thing here, which is actually the final image, but there is also another layer added, which is effects result. So here you will find all the effects, the final effects combined together, including the denoiser. So if you have added any other effects, you will see that here you will have the final effect. The denoiser has its own channel, which is this one. Okay, here you see the final render with the denoiser applied. It's evident that the image has no noise, actually not even in the volumetric fog that we have here in this area here, where you see the light rays coming inside the window. So denoiser is a very important algorithm that I do recommend that you use it in all your renderings as a final pass. Just remember that if you apply denoise to the final image, which is normal, you should also apply the noise to any channel that you might want to use in post-production. Else you will have noise inside some post-production channel that will be applied to the denoised image. So just pay attention to this if you're into post-production after V-Ray rendering. Remember yesterday we saw this kind of material, which was the glass Smoky with fingerprints, okay? And we decided that we wanted to apply this material, for example, to an actual object that we have here. I was thinking, well, actually this morning, I was thinking of creating quite a nice effect on this glass here, on this cup of this glass of wine, but it should be too difficult to do it in one single session. Well, actually, it would take the whole session to do what I wanted to do. I wanted to make some material with some lipstick on the edge of the cup and some droplets on the surface of the glass and so on. But it's going to take forever doing something like that. What I wanted to do right now is put some fingerprints on the edge of this. This is something that we were already discussing yesterday. So how do we do this? Because one thing is to have a material which is actually using, remember that in reflection and refraction, we put a texture, which is this one. So one thing is covering something with a texture, which is something that we already did also with the floor, right? So the floor is covered with a texture. But now what we want to do is we want to place this texture in a specific area of this particular object, okay? So it's a mix of two aspects, the thing that we must do right now. It's take the right texture and place it in the right spot of the object, okay? So it's a mix between texturing and texture mapping, okay? So this is not good for our task. I don't need this texture right now because this would cover the object with fingerprints. So I need to create a material which will be specific for this object, okay? No other object will be, let's say, suitable for working with this particular material. So what I'm going to do right now, I'm going to eventually duplicate this. Well, actually, the glass Smoky fingerprint is not assigned to any object in our scene, because if you remember, we were assigning this material to a glass panel floating here in between this volume, okay? So this is not assigned to anything. Actually, you can double check this and verify this condition. If you right click on the material and you say select objects in scene, if something gets selected, then this material is applied to that object. And it's very easy to understand if a material is assigned to an object. You just right click, select objects in scene, and zoom to selection. If Rhino say that no objects are selected, then this material is orphaned, basically. It has no object assigned. So I would work with this, but instead of naming glass smoky fingerprint, I will change the number to glass smoky fingerprint table, okay? Because there will be no other object suitable for receiving this kind of material, okay? Now, how do we apply a specific texture to a specific spot of the object? Well, in this case, we have an object that has basically it has a primitive shape because it's a cylinder. Even if it's very short, it's still a cylinder, okay? Um, and as this has a primitive aspect, then you can always texture map it, like going into properties and going into texture mapping, and eventually remove any texture mapping if you are not sure that if it already has some texture mapping applied. You remove it, and then you apply, for example, the cylindrical mapping. Now, cylindrical mapping, in this case, the only recommendation if you use cylindrical mapping is that you place the center of the cylinder in the center of the object, okay, in order to avoid any shifting of your texture. In order to do so, I'm going to disable the, enable the snaps, activate the center, place the mouse more or less in this area until I see center. So I'm sure that I'm taking the center of the base of this object. As regards the radius, it's totally irrelevant in terms of side projection, because I can take a cylinder this wide or this narrow. The projection will always be perpendicular to the boundary of the cylinder, okay? But if you select a cylinder which is wider than the object, what you are going to affect are the caps, the upper and lower cap, because it's going to be wider or narrower, okay? So I do recommend that in this case, for example, you take a cylinder that exactly measures the same size of the object that you want to map. And so in this case, for example, I would take a perpendicular to the outer edges. And as per the height, I will take this one. And Rhino asks if, because texture mapping is something that belongs to Rhino, not to V-Ray. V-Ray will use this texture mapping, but it's not part of the V-Ray workflow, okay? It works also with cycles. That's what I mean. If you want this mapping to be capped, then you just confirm that you want it to be capped, like here, okay? You just hit enter. If you don't want it to be capped, you click on no, but you won't be mapping the upper and lower surface of this cylinder, okay? And we want this to be capped. So I just hit enter, and now this object has some texture mapping. What's the problem in this case? The problem is that we have cylindrical texture mapping, but it's a, let's say, automatic mapping. So even if I use right now a material with some fingerprints, let's say the actual Smoky fingerprint material, Rhino will take the texture, let's focus on this. Rhino will take the texture with our fingerprints and spread it all over the upper surface, the lower surface, and all over the side surface, which is something like a cylindrical surface. So it's totally out of control, right? Because we don't control where the texture are going to be applied. It only depends on texture mapping. So even if this thing has a primitive shape like a cylinder, we cannot use cylindrical mapping if we want to use some texture that must be placed in a specific spot. Okay. So general rule: if you want to spread texture all over the surface of an object, then you can use automatic mapping if there is one that basically is suitable for that particular shape. But if you want to place a texture in a specific spot, you cannot use automatic texture mapping like any of these widgets here. You have to create a custom texture mapping. So first thing first, we must create a custom texture mapping for this object, okay? And I'm going to concentrate on this. So I'm going to invert selection, group everything, and hide everything. So everything is hidden but this object. I'm not going to move it because it is already in the right position, but I just want to see it isolated. So because we are going to work with a technique which is called unwrapping. Probably many of you, because I understand that you already do renderings and so on. Oh, by the way, sorry, I forgot to answer your question about animation. Yeah, I do not recommend to do animations in Rhino. There is a plugin for Rhino which is called Bongo that can be used to create animation. But I think, in my experience, the control that you have on the camera in Max is absolutely better than the control that you have here in Rhino. You can do several things in Max that you cannot do here in Rhino. Also, for example, I remember when I used to make animations, there were also some scripts that you could apply to cameras, and in order to simulate some kind of natural micro movement that are typical when you shoot a video with a camera. So just to simulate, for example, some light hand shaking or something like that. So it's a totally different approach with respect to what you can do in Rhino. So I would recommend you everything that has to deal with advanced camera settings. Maybe it's better to work with another platform. So it's like, for example, one thing that we are going to discover right now is that as regards our specific topic, which is UV unwrapping, for example, and custom texture mapping. Yes, we can do some things here in Rhino, but it's not the perfect environment to do something like this particular task that we are going to see right now. So there are some things that, yes, you can do in Rhino and V-Ray for Rhino, but there are better options for this. So I'm going to take this object here, go into texture mapping, get rid of the actual cylindrical texture mapping because it's useless for us. And what I'm going to do, I'm going to customize the way that this object is unwrapped. So in order to do this, I go here in this unwrap button, and Rhino asks, what are the seams of this object? Okay, so seams are edges of the object that will be cut during unwrapping. And so you will be able to either separate surfaces during the unwrapping, or to leave surfaces connected in a very specific way in order to create an unwrapping that doesn't produce distortion or deformation of the object while being unwrapped. So this is the main goals that we have. Now, this object has some filleting here in these edges. And this makes it a little more difficult to unwrap this shape because basically the shape, which if it was a regular cylinder, it should have only 3 surfaces. But now it has the standard 3 surfaces plus 2 fillet surfaces. Okay, so we must take into account also this situation. So for example, if this was a standard cylinder, I would use as seams the upper circle and the lower circle, and that's it. Okay, so now Rhino already knows what are the seams of this object, even if you don't see anything. Okay, and once you have specified the seams of the object, you go here in this button, which is the UV editor, and Rhino asks, we are going to discuss this in detail, this is just the general workflow, right? Rhino asks to draw a rectangle. And we would be discussing this in a while, but let me draw a rectangle here. So you see that now we have the unwrap of this object inside the area of the rectangle that I just designed, okay? And the problem is that if you take a look at this, you see that the unwrapping is totally messy as regards the side surface of this object, because there are 3 surfaces connected and with some deformation. So we must do something in order to avoid this kind of overlapping surfaces. So we need to cancel this UV editing. We need to delete the actual texture mapping and unwrap this again. So I'm going to select, yes, the upper circle, the lower circle. And well, actually, before doing this, I would recommend that you take the object, and as isocurves are well, actually, very disturbing right now because I want to concentrate on edges, okay? Isocurves, which are these lines here. I don't know if you're aware of isocurve meaning in Rhino, but this is not the point today. But anyway, you can select the object, go into properties, and don't show surface isocurves. So I don't want to see them. And if I don't see isocurve and take a look at this object, I find this spot here. And this spot here is actually the longitudinal edges of this cylinder, okay? So what I need to do right now is take this object and go into texture mapping, get rid of actual mapping if there is one, and unwrap this. So upper circle, as always, and lower circle. And as regards the side surfaces, I'm going to select this edge, this one, this, and this. Okay, so I'm telling Rhino that during the unwrapping, I want the side surface to be cut like this. So I expect to have a rectangular unroll of the side surface, right? Because this surface can be unwrapped vertically right now. So this is the rule that I want to use for the seams, and then I UV editor, draw this, and now we have the same two circles, but if we take a look at this is actually more regular than before. You see, it's a single stripe. Okay, so first thing first, you must define the cutting edges for the seam edges properly, else you will get an irregular unwrap and you will be in trouble. What is this thing that we created here? This rectangle here, or this square, like in this case, represents the texture that we want to apply. Now, when you use the UV editor, you see that another tab appears here. You can also move it away from this side, but I find it useful to have it docked here on the right. So you can decide if you want to highlight selected. You see that this is something that has to do with the object. If you want to show the wireframe, you can do it. But the wireframe that you are seeing is not the wireframe from the object, as you can see. This is the mesh wireframe. So we got to probably one of the main aspects of rendering. So the object that you render in Rhino, even if you are working in Rhino, which is a NURBS modeler, are meshes. And so what you see here is the actual mesh representation of your table here, unrolled and unwrapped and unrolled on the plane, okay, on the XY plane. So the show wireframe is not showing the actual wireframe of the NURBS object, but the wireframe of your mesh object. And this mesh object is created automatically. So why do I say that Rhino, yes, allows doing some unwrapping and texture mapping, but it's not the best option because you don't have absolute control over the topology of the mesh. And so you will most likely get this kind of weird meshes with a huge amount of triangles, with polygons that have a very variable, absolutely variable size, so and aspect ratio. So it's very complex to create a controlled texture mapping in Rhino. Eventually, later on, I will show you some unwrapping and texture mapping that I have just done in Blender, which is absolutely better for this kind of applications. But in this case, let's stick to what we have, and let's do the maximum we can with these tools. Okay. So show wireframe is more or less useless because it also, well, normally you would do this in order to better understand in what part of the texture you are with respect to the application point of that texture over the object. But you should be able to recognize the topology of the mesh. Well, it's very difficult to understand where this point corresponds on this object because the mesh is totally irregular. Okay, so that's the difficulty that you have when you activate the show wireframe. And if you have a material with a texture already applied, then you can stick to use material. Okay, but if not, let's see, like in this case, we have the material, but we have no texture, right? So there is actually no texture projected on the surface of this object. And so we must approximate or just study this case here with a texture. And the standard texture is a checker with numbers. So now we can clearly understand that this is the upper surface because we see number 51 and we see it here, while there is 81 here. And if we go on the bottom, you see 81 here, okay? And as regards the side flows through cells number 30 to number 39, okay? Remember that our seam point was somewhere here. And so we have all the stripes here, the side surface is actually receiving this part of the texture, okay? So if we put a texture here, and we want fingerprint on the top surface of our table, we must place the fingerprint texture in this area that corresponds to square 40, 41, 42, 50, 55, 50, well, 51 probably not because it's absolutely right in the center. So unless you want to place a palm print here in the center, you don't do that. But if you want to place, for example, fingerprints here, more or less in this area and this area, like if somebody was dragging the table around, then it's 40 and 42. So we know exactly where to place the fingerprints, okay? So this is basically the technique of seam marking, or let's say unwrapping, and applying via the UV editor a texture to the object. Actually, this is the standard checker texture with number, but you can also create texture if you want to create a new one. Normally, I would recommend that you work directly with the material, okay? So let's see how we can place fingerprints exactly in this area, 40 and 42, okay? Of course, we need some photo editing in order to do this, okay? So eventually, what I'm going to do, I'm going to quickly open Photoshop. In the meanwhile, I'm going to prepare things a little. So I'm going into the top view, and we could also do some tweaking of this unwrapping that happened, because eventually you see that the two circular surfaces are basically unwrapped correctly because they have circular aspect, and despite the mesh, which is totally messy, but we have circular shapes that do represent the object. But this thing here, which is selectable, by the way, and you can see that when you select it, you have the correspondent part of your object selected as well, so you can recognize which part is which in the object. This is good for complex objects, not in this case, because it's very simple to understand which part is this one. But the thing is that this thing, if you remember, we saw this from the side, is totally irregular. You see that it's like moving, like it's a wavy unroll, what happened. So you can also give this thing a more regular aspect, because this is a mesh, okay? Even if it's a temporary mesh, because it's visible only while you are in the UV editor, you can still edit this mesh. So if I take this mesh object and activate the control point, I have access to the vertices, okay? And if I want to stretch this object, for example, what's the meaning of stretching this? Now this object is receiving part of the height of this stripe of square. But if I want this object to receive the whole height of these stripes, this stripe of square, I can take all of this and start doing something, scaling it up and move it a little and rotate it like this. And now the whole stripe here between 30 and 39 would be projected in the thickness of the table, okay? So this is good if you want to have more room for creating your effect. You can stretch this and work on a wider area in your texture, okay? But the main problem is that we have this wavy aspect. So we can also work with point editing in order to make this shape more regular. This is something that is well, actually texturing is a job, okay? Texture artists are basically professionals that spend their lives doing this kind of operations, okay? This is something that eventually you might want to do for very particular things. But if you go into point selection in Rhino, you can also use this tool. Well, actually, it doesn't recognize this because this is a mesh. It's right. So you must select this by hand. unfortunately. And in order to make this thing regular, I'm not going to do this, don't worry. But you can use, for example, command like set point and set the y coordinate for all of these points and align them. Okay, if you do this with all these lines of points, then you can easily, well, more or less easily, make this mesh more regular. The other thing that you can do before unwrapping the object is changing the mesh properties of this object. So you can select the polysurface in this case, you go into properties, and you will create a custom mesh. In that case, you might be able to create a more regular mesh representation, and therefore an easier way of tweaking the texture mapping of this object. Okay, but it's very unlikely that you can do this because meshing or mesh conversion is almost always automatic in Rhino, unless you have very regular shapes. Okay, and the fillet that we have in this part, and the fact that we have some round border or circular border in these surfaces makes it impossible to have a regular mesh in Rhino. Okay, so let's go back to our texture. Let's say that we have this distribution here. You can also tweak things in order to make the texture, to optimize the texture. For example, I want to work in with a smaller image. Okay, so there is this texture here. If I know that I can distribute my pieces in this way, instead of designing a square like this, I could also draw a rectangle, which reduces the size of the image. Remember that textures are loaded into RAM in the moment you create the rendering. So if you work with high resolution texture and you work with a huge size of the texture, you will have images that have a file size of several megabytes. And those megabytes are going to be stored in the RAM during the rendering process. So RAM is important while rendering because it receives all the texture that affect your material and your environment. Remember that we are also using an HDRI texture that weighs something like 40 megabytes, if I don't remember wrong. But anyway, everything goes into RAM. So you need a lot of RAM if you work with high resolution textures. But anyway, we have this situation here. So what I'm going to do, I'm going to take this, and now there is one particular feature in Rhino 6 that was not present in previous versions. That is the capture to clipboard or to file. It doesn't matter actually. I want to just capture this and have it as a reference in Photoshop. Okay, so I'm going to capture this to clipboard, and the feature is that you can decide the scale. So if you want to create a high resolution version of this screenshot, you can scale this up, like for example, twice the actual size, so you get a resolution of 2640 instead of 1320. Okay, I'm going to keep it low because I don't want to work with high resolution texture. I just want to concentrate on the process, but you can do this. And it's very nice to have this feature because you can create screenshots and place it into, I don't know, presentation drawings and so on. So I'm going to hit OK. Always wait for the cursors to blink again, okay? Because if you switch window before this happens, probably you will miss the capture, okay? So I'm going to Photoshop, I'm going to create new, and I'm going to use the custom because, well, actually, I don't see the actual size. I should see it here. So this tells me that the clipping, the capturing didn't succeed. So let's go back here to Rhino, and let's capture this again to clipboard. I should notice a 1320 by 747. So let's see. Create new, and here it is. Okay, you see that you have to wait for that moment. So create this, paste my reference texture, and now what I'm going to do, I'm going to place some guides in order to perfectly select the area that I want to work in. So it's going to be like this. I'm using Shift key to place the guides. This is something that might look like off topic, but it is not. Okay? This is something that it's real life when you create some complex texture mapping. And then I simply use a rectangle selection like this and image crop this. So I have a perfect representation of my texture. And what I want to do, I want to place fingerprints. I changed the position, so let me double check. I have 44, 45, 46, so I need to work in the right circle area, like here. And I want to place my fingerprints here in these areas, right? So we already have in our folder, these are the textures that I sent you. We will use them in a while, but we also have this fingerprint here. Okay, so first thing first, I'm going to drag these fingerprints here inside this area. The fact that we are working with a low resolution image also allows me to use these fingerprints because they are low resolution. Okay, if this was a high resolution texture, this object would be very, very small. Okay, which is not a real problem because the fingerprints are not a continuous set of pixels. They are naturally pixelated. So it's not a huge problem. But nevertheless, you might want to work with images that have the same resolution, more or less. I'm going to change this to, I don't know, something like screen eventually, or something like overlay, or something like multiply, if I want to overlay the actual reference to what I'm doing below. And I'm going to lock this in order to don't move it around. And so I want to place my fingerprints here in this area and this area. So I'm going to take this, eventually also duplicate, well, actually the Alt key makes this available again. So I'm going to duplicate this. Yeah, so I have two. And so I'm going to place this one here. I'm going to rotate it in order to have the fingerprints oriented properly. And I'm going also to scale it, because if my thumb was this size compared to this table, I should be a giant. So I'm going to decrease this size, place this thing here, apply a mask, and brush something with a smooth and a soft brush, like with black color, in order to get rid of this part here. Eventually, especially this part here. Not the exterior, because the exterior, I don't want the exterior to overlap to this side surface here. So I am only deleting the overlapping that happens with this stripe, the upper stripe. But as regards, for example, this part here, I don't need to get rid of this, because there is no part of the object that corresponds to this particular spot of the texture. So the only thing that I want to take into account is what happens inside the surface of my table. Okay, so I don't care about this area. This area, I can leave it like this. And so this is the first part. And eventually I'm going to get rid of this and duplicate directly this texture, so I can move it, and it's already more or less the size and already blurred and so on. Eventually, if I work with the same texture, I will have the same effect. So I don't know, probably I would depaint or demask these things and move it in a different area like this, and repaint it with black in order to have the proper set of fingerprints. If you add some noise, for example, to your brush, then you will have a better, let's say, smoothing or more irregular fingerprints in your scene. So this is going to be my texture. And now let's understand what type of texture we are working on. No, so we know that in our material, this object here has this texture applied to reflection glossiness, and so we had also to invert this thing in order to make it black on white, and black being turned down or getting desaturated, or with a different value for the grayscale, in order to have it more light gray than black. So let's go back to here. We have the opposite situation. So I'm going to apply an invert filter. So I have black on white. This also tells us that this background must be black as well. So I'm going to default G, apply black to this, and now invert, and we have the black on white situation. Don't worry about this sharp edge here because it doesn't lie on any part of our object. And therefore, I can also apply some, well, normally I work with exposure, even if brightness should be enough for now. But if I do this, I have exactly the effect that I am looking for. So let's see what happens if I work with this texture. I'm going to save it like in our V-Ray. Yeah, I'm going to save a JPEG file, and this is going to be our glass Smoky fingerprints table. And always append some information about what texture you are creating. And this is reflection glossiness, okay, or like this. Let's give it the quality we want. We are working low resolution. You saw it was 50 key, so it's very, very light file, this one. And let's go back to our V-Ray material. So now I'm ready. I'm ready to change this to our new texture, which is going to be this one. Okay, so you see it's this one. I don't need to invert it anymore. I don't need color gain anymore, so I can leave it exactly like it comes from the import that I am doing. Okay, so this is the reflection glossiness parameter, and we also had refraction because we added the same image to transparency. So I'm going to go here, load the same image. Oh, by the way, yeah, exactly the same image. You see, we also inverted and applied color gain, so it's going to be exactly the same process. Always double check that the set of transform that you created is actually reproduced in your texture. So you see that there is nothing here because you see nothing here in the preview because you are custom mapping an object. Okay, so if I now apply this texture mapping to my object and I select the object and apply this to selection, what I expect to happen is to have fingerprints here and here. Okay, so let me unhide everything, and also let me do something like this preliminary position, and then hit F6. Oh yeah, it's quite good. It's quite good. I should see fingerprints here and here. Okay, so let's double check if. Oh, let me save this. By the way, saving is always a good option. Sorry for going a little fast, but it's we have to see many things yet. Yeah, you see that we have fingerprints here. You already see that this blurred area that corresponds to our fingerprints. So we did it. We can also eventually, let me see if we can, yeah, we can move quite smoothly. And I don't want to lose the focus on this reflection. So if you work with a high resolution texture, for example, and then you will be, and with also a higher resolution texture for the fingerprints, then you might be able to also to recognize the fingerprints one by one. But we are working with a low resolution version, so it's very unlikely that you can recognize that detail on this kind of texture. Okay, even if you get closer, you might notice some distortion due to pixelation, but not exactly the fingerprints. Okay, so this is due to the resolution that we are using. But then, nevertheless, we absolutely succeeded in applying this custom texture to a specific spot via custom texture mapping. Okay, so that's the work that you might want to do with complex objects. Now, what's the limit, for example, here in Rhino? Imagine applying this workflow to this object here, the legs of this table. In this case, there is no way that you can do this in Rhino. Okay, so if you want to apply custom texture mapping to this object, you are in trouble if you're working in Rhino. But if you work with another software, which could be any polygonal modeler like Blender, Max, or anyone, you can, for example, the process normally consists in a pass which is called Retopo, where you take the high resolution mesh and create a lower resolution version of this thing, controlling the polygon position and shape all over the surface. Because that low resolution object can be easily unwrapped. Well, easily in another platform, not here in Rhino. Okay, so you can unwrap the low resolution and use that UV mapping in order to apply the material and the texture exactly as you want over the surface of this complex object. Not here in Rhino. In Rhino, right now with V-Ray, you have two options. Well, of course, as we did already, is applying some primitive texture mapping that takes into account the different orientation of this object in space. And the more likely we are going to work with spherical mapping as we did, okay? But there is another option which is available since the latest versions of V-Ray. No matter what V-Ray, for Rhino, SketchUp, Max, it doesn't matter. Normally they are more or less aligned with the same features, especially with the latest versions. Actually, V-Ray for Rhino was always the last to be updated, but actually it is in line with the other versions. The other option that you have is going into materials, and I don't know if you already looked at this by yourself, but there is a new texturing that is available, well, relatively new texturing available in V-Ray, which is called Triplanar. Now, I'm not going to use it because actually Triplanar, in my opinion, works perfectly if you don't have a closer look at the details of an object. So if you see something from the distance, you can work easily with Triplanar mapping. But if you are doing a close-up rendering, you always see something bad from Triplanar texturing. But triplanar texturing is something that I will show you here with a quick drawing, how it works. So imagine that you have this simple geometry here, like a cube. Triplanar texturing allows to project onto this object 3 different textures from 3 different directions. So let's say you want to apply the one texture in the X direction, another texture from the Y direction, and another texture in the Z direction, okay? And triplanar texturing allows also to blend or create blend zones between these 3 directions. So if you have a cube, you will have the texture exactly projected onto this face and to the opposite face, of course. But if you have some organic shape and you use triplanar texture, then you can blend this texture projected onto the surface of this object in these areas. No, the organic area that gets from the projection of these Z, X, and Y can be blended in these areas. And so you have a smooth transition between this texture here and this texture here in a controlled width. And the same happens here and here. So if you see it from the distance, you see seamlessly the texture flowing from one orientation to another one. And this is good for this kind of geometry, but only from the distance. Because if you get closer, you will see some weird overlapping of the textures in these areas. There are some parameters that you can tweak with triplanar texture, but it's not like unwrapping. Unwrapping is the best thing that you can do if you want to create some complex texture mapping, okay? So unwrapping this cylinder was very easy, but unwrapping complex things is complex, okay? Normally, for example, imagine, for example, unwrapping a tree. So the trunk, the branches, and so on. So that's already somehow more complex, okay? Without reaching this kind of complexity like the legs of this table or this object here, this is going to be quite a mess. So in this case, if you looked at this from the distance, you could use triplanar texture.